Hello everyone. Today we are going to start class 8 mathematics chapter number 1, which is rational numbers. This is lecture 01, and in this we are going to study about what are rational numbers, how they are classified, and how can we add two rational numbers. Right. So let us start with the definition of rational numbers. A number of the form P upon Q, where P and Q are integers. Later on I will tell you that these integers P and Q should be co-prime, right? It is desirable that P and Q should be co-prime, but for now let us take that a number of the form P upon Q, that is a number which is already expressed in a fraction or which can be expressed in the form of P by Q, that is in the form of fractions, where both numerator and denominator, that is P and Q, are integers and Q is not equals to 0 is called a rational number, right? So what is a rational number? What is the definition of a rational number? Any number which is either in the form of a fraction or can be expressed in the form of a fraction where both numerator and denominator are integers and Q should not be equals to 0. It is called rational number, right? So you will ask, sir, please give me some examples. So let us take some examples and get the concept clear. For example, 2 upon 5. Clearly 2 upon 5 is a fraction where both 2 and 5 are integers and 5 is not equals to 0. So it is a rational number. Also, you can take minus 1 upon 8. Clearly both numerator and denominator are integers and the denominator is not equals to 0. So it is also a rational number. You can say 5. Now 5 is an integer, but you can write it as like that. That is 5 upon 1. So you can express 5 in the form of P upon Q. So again it is also a rational number. Even 0 is a rational number. You can write it as 0 upon 5 or 0 upon 8 or 0 upon 7 or any number. You can take 0 upon something and that something should not be equal to 0. That is, denominator should not be equal to 0, but on the numerator side you can take it 0. So 0 is also a rational number. Similarly, you can take 5 upon minus 3. Now again both numerator and denominator are integers, denominator is not equals to 0, so again it is a rational number. So in this way you can take various examples and verify that what is a rational number and what not. Now let me give you the logic behind why we can take 0 on the numerator but not on the denominator. Suppose you write 0 upon 2, then you know it is 0. Do you know why? Because when you multiply 0 with 2, that is, you cross multiply the denominator 0 with the 0 on the right hand side, you will still get 0. This is true. But 0, when 0 come in the denominator part, okay, this is the same 0, but now it is in the denominator of something. Let us say that it is 2 upon 0, right? Now do you know 2 upon 0 is not defined? Do you know why? Because if we take it as some number x, then following the above principle, that is cross multiplying, we will get x into 0 equals to 2, which is false. Because we all know there is no value of x, which when multiplied with 0 will give you 2. So 2 upon 0, or for this thing, something upon 0 is not defined. You cannot take 0 in the denominator of a fraction. Now you understand the logic, because when you cross multiply, if it exists, then you can cross multiply 0 with that number, but again it will result in 0. But our result is not 0, it is 2. So this equation is false. That is why numerator can come in numerator but not in, 0 can come in numerator but not in denominator. So this was all about introduction of rational numbers. Now here one more point arises, that see, in all of these numbers there is nothing to be cancelled from numerator and denominator. That is, all of them have nothing in common. I could have written 10 by 5, then you could have cancelled 5 from it and you could have write 2. So it means that in a rational number, a number to be rational, it should be in the form of fraction, but this does not mean that the fraction is in the simplest form or in any other form. So we can play with the numerator and denominator. That is, if p upon q is a rational number, then if we multiply both numerator and denominator with the same number, then also it will be a rational number, and even it will be equal numbers. Example. Let us take the example 1 upon 2. Okay, it is a rational number. Now let me multiply 1 by 3 and 2 also by 3. So we will get 3 upon 6. Right. Clearly 1 upon 2 is 0.5 and 3 upon 6 is also 0.5. So they both are essentially same, but they both are also rational numbers. Similarly, if p upon q is a rational number, then you can divide both p and q with the same number and the fraction will not change. Right. Again example. Let us take this example. Let us take 3 upon 6. Let us take 3 upon 6. And let us divide both numerator and denominator by 3. So we will get 1 upon 2, which is again a rational number and equal to or equivalent to 3 upon 6. So these are equivalent rational numbers. Here 1 upon 2 and 3 upon 6 are nothing but they are equivalent rational numbers. So it is very easy to play with the numerator and denominator of a rational number. But yes, you have to take care that both the numbers which are being multiplied should be same. Similarly, you have to divide with the same number on both numerator and denominator, and it will not affect the rational number as whole. Okay, so this was all about introduction of rational numbers. Now let us move to the classification of rational numbers. Now what is the difference between definition and classification? Now classification tells you the position where rational number lies in the chart of number systems. Now what are number system? All the numbers which we see are part of number system and they are placed somewhere in that flow chart. This number system is divided into two parts, which are real numbers and imaginary numbers. Since imaginary numbers are not in our syllabus, we'll talk about real numbers. So all the numbers which we see around us are real numbers. Let it be positive, negative, zero, fractional, decimal, under root, square roots, okay, anything. Any number that you can imagine is real number in our environment, right, around you. These real numbers are divided into two parts. The first one is rational numbers, which we are studying currently. And the second part is irrational numbers. Now what are irrational numbers? Numbers which cannot be expressed in the form of p by q. Okay, irrational numbers. These irrational numbers do not have any other classification. Real numbers are represented mostly by capital R and rational numbers are represented mostly by capital Q. And you will also find that irrational numbers are represented by capital T. So all the collection of rational numbers is represented by capital Q. Okay. Now these rational numbers are also classified into two parts, which are integers and the second one are non-integers. Now what are non-integers? Which are not exact. That is, sir, they are fractions. Yes, fractions. You can also call them decimals, because ultimately a fraction can be converted into decimal if we divide the numerator by denominator, right? So these are the classification of rational numbers. Now again, non-integers do not have any other classification, but integers can be further classified into negative integers, 0 and positive integers. So integers can be classified into negative, 0 and positive. And you all know positive integers are nothing but natural numbers. Similarly, if we add 0 with the positive natural numbers, we will get whole numbers. And there are other kinds of numbers like prime numbers, composite numbers, co-prime numbers. All of those are part of natural numbers. So this is the classification of real numbers, and now you can see the position of rational number. That is what we are studying. So we are essentially studying all of these, that is integers, non-integers, negative, positive, 0, fractions, decimals. So this is the classification of rational numbers. For your reference, there is a figure. You can see in this figure, rational number consists of integers and non-integers. See, 4 upon 8 is not an integer, minus 0.5 is not an integer, minus 0.33 is not an integer. So everything outside this oval shape is non-integers. Now this oval shape contains integers, so there are two parts, integers and non-integers. Okay, in these integers also you can see there is an oval out of which there are negative numbers and inside which there are positive numbers. So there is negative and positive, and they've classified it like negative, positive and 0. So negative numbers are outside this small oval and 0 and positive numbers are inside an oval, inside this oval. These are the set of whole numbers. Okay, so this is the classification of rational numbers. Now let us move to the lowest form of a rational number. Now what do we mean by lowest form of a rational number? We can divide numerator and denominator by the same number. Why do we do so? To cancel out the common factors. And why do we cancel out the common factors? To bring the rational number into its lowest or simplest form. So we can define a rational number P upon Q is said to be in the lowest form or simplest form if P and Q have no common factor, if P and Q have no common factor other than 1. Now you all know that two numbers which do not have any other common factor than 1 are called co-prime numbers. So P and Q should be co-prime numbers. That is why I insisted in the definition part that for a rational number to be defined, P and Q should be co-prime. If they are not co-prime, we can make them co-prime by cancelling out the common factor. That is what we are doing in this topic. Okay, so let us take an example. Clearly 4 upon 6 is a rational number, but it is not in the smallest form, in the lowest form. We can divide both 4 and 6 by 2 and we will get 2 upon 3, which is a rational number and also in the simplest form. Similarly, you can take one more example as 12 upon 24, right? Clearly they have some common factors, but they are not visible easily. So let us carry out the simplest form or the lowest form or the factorization step by step. Let us first divide both numerator and denominator by 2. Let us do it in multiple steps. If you have a problem, you can do it like this. You see, these both are even number, they should be divided by 2. So you will get 6 upon 12. Again, you see that they both are again even, so you can again divide them by 2. So you can carry out the same thing in the multiple steps. See. So again you will get 3 upon 6, right? Again you can see that yes, they can be divided again by 3. So you can divide them both by 3. And you will get 1 upon 2, which is the simplest form. So you could have divided both numerator and denominator by 12 itself and you could have directly got 1 upon 2. But you can do it in multiple steps to avoid mistakes, right? So this is what lowest form of a rational number looks like. Now let us come to the next topic, which is equality of rational numbers. When do we say that two rational numbers are equal? So let us define that. Let us define the equality. Two rational numbers P upon Q and R upon Z are said to be equal. Two rational numbers P upon Q and R upon Z are said to be equal if P into S equals to Q into R. Right. So two rational numbers P upon Q and R upon S are said to be equal if P into S equals to Q into R. Now, how do we got this situation? So what was our purpose? Our purpose was to equate these numbers. So let us take these numbers to be equal. Now cross multiplying the numerator on the left hand side with the denominator on the right hand side, and denominator on the left hand side with the numerator on the right hand side, we will get P into S equals to Q into R. So this is the condition which we obtained by equating these rational numbers, right? You can also remember this like this. We essentially multiplied by cross multiplication. So you can remember this cross multiplication by this figure. Now let us take an example to illustrate its use. Let us verify that minus 7 upon 21 equals to 3 upon minus 9. Now they are not looking equal, but let us verify if they are equal or not. So by following this diagram, we can write it as, if they are equal, then they can be written as minus 7 into minus 9 equals to 3 into 21. Now let us see if this equation is true or not. Minus 7 into minus 9 is what? Minus into minus becomes plus, and 7 into 9 becomes 63. Similarly, 21 into 3 becomes 63, which is true. So since this equation is true, therefore these numbers are equal, and you can easily verify if you carry out cancel out 7 from numerator and denominator. Similarly, if you cancel out 3 from numerator and denominator, you will get minus 1 upon 3 equals to minus 1 upon 3. So yes, they are equal numbers. So this is all about equality of rational numbers, right? So two rational numbers are equivalent if and only if this condition is followed, and you can remember this condition by this diagram. Okay, so let us move to the next topic, which is addition of rational numbers. That is how two rational numbers can be added. Now there two scenario arises: when the rational numbers are with same denominators and when the rational numbers are with different denominators. If the rational numbers are with the same denominators, then we can directly add them. For example, if P upon Q and R upon Q are rational numbers, then P upon Q plus R upon Q equals to P plus R upon Q, right? So you can directly add the numerators when the denominators are same. Let me present an example. Let us add 3 upon 5 and 11 upon 5. Let us present 3 upon 5 and 11 upon 5. Now 3 upon 5 plus 11 upon 5 is nothing but 3 plus 11 upon 5. Okay, it is nothing but 3 plus 11 upon 5. So using this rule, we can get numerators to be added, and we'll get 11 plus 3, that is 14 upon 5, right? So this was all about addition of rational numbers with same denominators, right? Clearly it was very easy. You just have to add the numerators because the denominators are already same. Let me present one more example. Of as how can we add different rational numbers. Let us add 4 upon minus 11 and 7 upon 11. Now you will say, sir, the denominators are not equal. One is 11 and one is minus 11. That is why I have given this question. Let us solve it. Now 4 upon minus 11 is nothing but minus 4 upon 11. You can put minus anywhere on numerator, on denominator, or on the fraction. Okay, because the minus is on the fraction itself. Minus 1 upon 2 is also 0.5. Let me show you. Minus 1 upon 2 is equals to minus 0.5, right? 1 upon minus 2 is also minus 0.5. You can also write it as minus 1 upon 2. Okay, let me represent it like this. Minus should be on fraction, neither on numerator nor on denominator. Again, it will be minus 0.5. Okay, so it does not matter where the minus is kept. So 4 upon minus 11 is minus 4 upon 11. Now what we have to do? Now we have to add minus 4 upon 11 and 7 upon 11. Again, following the same method, taking 11 as the common base, we can add minus 4 plus 7, which will give us 7 minus 4 is equals to 3 whole upon 11. So this is how you can add rational numbers with the same denominators. Now let us talk about the rational numbers which have distinct denominators, right? That is, which cannot be added in this way. So there are rational numbers which have distinct denominators, and if you have to add them, then you have to take the LCM of the denominators, right? Let me present an example and then I'll show you the method. With the help of example, we'll understand the method. Let us add 5 upon 12 and 3 upon 8. Okay. Now 5 upon 12 plus 3 upon 8 is equals to, clearly you have, for adding them you have to make the denominator same, but they are not same, so we will make it same. We can take the LCM of 12 and 8 because we know that LCM would be a number which is both in the tables of 12 and 8. So let us take the LCM. Let us take the LCM of 8 and 12. With the help of prime factorization method, we will divide both of them by 2. We will get 4, 6. Again, we will divide them both by 2. We will get 2, 3. Again, we will divide them by 2. Now this has become 1, but this is still 3. And now we will again divide by 3 and we will get 1, 1. So this is the method in which we will calculate the LCM. We have to divide all the numbers whose LCM we are calculating till the time they become 1. Okay. So LCM of 8 and 12 would be the product of all the factors, that is 2 into 2 into 2 into 3, which is equals to 8 into 3, which is equals to 24. Right. So we got 24. Now how can we make 12 24? By multiplying it by 2. But we have studied that if we have to multiply denominator by 2, we have also to multiply numerator by 2. So it can be written as like this. Plus, similarly we have to multiply 8 by 3 to make it 24. So we have to multiply numerator also by 3 to make it 9. So it will become 10 upon 24 plus 9 upon 24. See, 10 upon 24 is nothing but the equivalent rational number of 5 upon 12. Similarly, 9 upon 24 is nothing but the equivalent rational number of 3 upon 8. So now we can add them with the regular method, which is taking the 24 as common denominator and adding 10 plus 9. And we will get 19 upon 24, which is the required sum. Okay, let us take one more example to understand it better. Simplify. 8 upon minus 15 plus 4 upon minus 3. Okay. Now here, first of all, we can write them as minus 8 upon 15 plus minus 4 upon 3. Right. So we have sent the negative on the numerator part. Now what we have to do? We have to take the LCM of 3 and 15. But again, we know that LCM of 3 and 15 is what? 15. Let us verify. let's divide by 3, we will get 1 comma 5, and then we will divide by 5 and we'll get 1 comma 1. So the LCM is 3 into 5, which is 15. Okay, so how do we make them 15? It is already 15, so no need to multiply them with anything. But to make it 15, we have to multiply 3 by 5. Okay, we have to multiply 3 by 5, and similarly we have to multiply 8 also by 5. So we will get minus 8 upon 15 plus minus 40. Okay. So there is minus, so there was minus 4. There was not 8, it was minus 4. So we have to multiply minus 4 by 5 and we will get minus 20 upon 15. So the answer would be minus 28 upon 15. Right. So this is how you can calculate the sum of rational numbers which have distinct denominators. So I think the lecture is pretty clear. Okay. We'll meet in the next lecture. Thank you for watching this lecture. Goodbye.